Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We have started a discussion with the chapter Circles. We learned the basics of circle, circle equation and the equation of tangent, pole, polar and all other things, right? And we are in the discussion of tangents of two circles, that is how many tangents do they have or how many common tangents or else are they transverse or direct. And not only that, we also learned the condition whether two circles touch each other or not, right. Let us continue the same topic, shall we? See here, the first question given us, show that the circles, this circle and this circle touch each other, okay. And the next he is also asking us to find the point of contact and the equation of common tangent at the point of contact. Clear? How do we prove that both the circles touch each other? C1 C2 is equal to R1 plus R2, isn't it? So first let us find the centers and radii of both the circles and let us check whether two circles are touching each other or not. Next he is asking to find this point of contact. How do we find the point of contact? That is by the same whichever we did as internal center of similitude, right. Similarly we can do here also. And finally how do we find the common tangent? Using the same point we can find the tangent of the circle, okay. See here, first let us write the two equations, okay, that is x square plus y square minus 6x minus 2y plus 1 is equal to 0, and one more is x square plus y square plus 2x minus 8y plus 13 is equal to 0, right. Can we find both the centers now? Here the C1 is 3 comma 1, here C2 is minus 1 comma 4, isn't it? Is there any doubt in finding that? It is 2gx and it is 2fy and it is minus g, that is negative of half of x coefficient, here also negative of half of x coefficient. And the next R1 under root 9 plus 1 minus 1 and here R2 1 plus 16 minus 13, clear. So what do we get as R1? 1 will get cancelled, R1 is 3, R2 is 2. Why? 16 minus 13 is 3, 3 plus 1 is 4, square root of 4 is 2, okay. So let us find the relation, that is C1 C2 and R1 plus R2. First let us find C1 C2 ka distance, okay. Minus 1 minus 3, 4 minus 1, what is it? Minus 1 minus 3 is 4, 4 square is 16, 3 square is 9, 16 plus 9 is 5. This is C1 C2 ka distance, okay. Similarly can we find R1 plus R2? R1 plus R2 is however 3 plus 2 which is 5, isn't it? So is the two circles touching each other? Yes, right. So therefore C1 C2 is equal to R1 plus R2, therefore both circles touch each other, right. What is the next condition now? He is asking to find the internal center of similitude, that is nothing but the point of contact. How do we find? Just tell me. This is one circle, this is one more circle, right. C1 C2, this is R1 and this is R2, right. We could find that C1 C2 ka distance is equal to R1 plus R2, yes. So now we have to find this point of contact. How do we find? The same thing, this point divides the line C1 C2 in the ratio R1 plus R2, okay. So let us write ratio R1 is to R2 is 3 is to 2 and the points are 3 comma 1 minus 1 comma 4, okay. So the point of contact is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, yes. This is m and this is n, isn't it? So we can write it as 3 into minus 1 plus 2 into 3 by 3 plus 2 comma 3 into 4 plus 2 into 1 by 3 plus 2. Now minus 3 plus 6 by 5, 12 plus 2 by 5. What is the answer? 3 by 5, 14 by 5. Isn't it? This is the point of contact. Yes, what is that next we have to find now? We have to find the common tangent at the point of contact. How many common tangents do we have? 1, 2 and 3, but he is specifically asking the tangent at this common point. So, you can use this point and take one of the circle and find the tangent. That is one case. And one more new thing which we are going to learn from here is, if two circles are given, then the equation of common tangent can be written as s minus s dash is equal to 0. Let us say first equation as s and second equation as s dash, right. So, whatever the common equations between two circles are there, that is common tangent, polar, chord of contact, okay. These kind of equations are nothing but s minus s dash. So, let us subtract these both equations, that is x square plus y square minus 6x minus 2y plus 1 minus second equation. Let us subtract everything, minus x square minus y square minus 2x plus 8y minus 13 is equal to 0. Clear? So, let us cancel all those x square y square, and the next minus x minus 2 is minus 8x minus 2 plus 8, that is 6y, 1 minus 13 is minus 12. We can take minus 2 as common, I will get it as 4x minus 3y plus 6. So, the equation of common tangent is 4x minus 3y plus 6 is equal to 0. Is it right? Did you understand till here? What is the main thing we have to remember? First, read the question, do not get confused. He clearly told that, show that two circles touch each other. How do we do? Just we will find centers and radii, and we will find check whether C1 C2 is equal to R1 plus R2 or not, right. After that, he is asking us to find point of contact. How did we find in the last sessions? That is by taking this point, dividing the whole line C1 C2 in the ratio R1 and R2 and finding the point using section formula, isn't it? And the next thing, find the common tangent at the point of contact, right. One thing we know is, we will take this point, we will use S1 equal to 0 formula and find the tangent of any one of the equation. We can directly get this, or else the simplest and the new method is, whenever you are finding the common tangent at this common point of contact, we have to do just s minus s dash equal to 0. Clear? Did you understand? Is it not easy to solve? Fine. Shall we move on to the next problem? Let's do. Look at the next question here. He is telling that, show that the circles touch each other if 1 by a square plus 1 by b square is equal to 1 by c. How do we prove? The first condition is, we have to find centers C1, C2, R1 and R2. What is C1 here? Minus a comma 0, isn't it? What is C2? 0 comma minus b, right. And the radius R1 is under root a square minus c, and here R2 is under root b square minus c, isn't it? What is the formula of radius? G square plus f square minus c. Here however g is 0, f is b square, and here it is minus c. And he is telling that two circles touch each other. What is the condition? If two circles touch each other, then C1 C2 is equal to R1 plus R2. Okay. So, now let us find under root 0 plus a square minus b minus 0 is b square, R1 plus R2, that is a square minus c plus under root b square minus c. Okay. So, everything is in square root. So, let us square on both sides. Okay. If I square on both sides, what do we get? Square of a square plus b square is a square plus b square, and here this is a and this is b. This will be a square plus b square plus 2ab. Clear? A square plus b square plus 2ab, isn't it? So, let us bring all a square b squares on one side. What do we get? If you observe a square b square will get cancelled. I will be left with 2c. Okay? Yes or no? So, since again we got a square root, let us square it on both sides. Let us square on both sides. Then we get it as, here also we can cancel 2 c square is equal to a square minus c into b square minus c. Yes. So, let us multiply and simplify, right. So, we get it as c square is equal to a square b square minus a square c minus b square c plus c square, right. So, let us bring everything to left side and keep only a square b square onto the right hand side. So, we will get it as a square c plus b square c plus c square, and the c square will come this side. Here we will get it as a square b square minus a square, sorry, here we get it as only a square b square. Clear? If you observe c square will get cancelled. Can we take c common here? I will get it as a square plus b square, right. Let us send this c that side, a square b square this side. This will become a square plus b square by a square b square by 1 by c. Let us separate the LCM. We get it as b square will get cancelled, a square will get cancelled. Therefore, 1 by a square plus 1 by b square is equal to 1 by c. Is it right? Clear? He is telling that show that the circles touch each other if this condition is satisfied. So, we did ulta. We have we have proved this. So, we can tell that these two circles touch each other. Is it clear? Once again, what is the main thing we have to remember here? Whenever we get two circles, find center, radius, and later check whether both the circles touch each other or not. Clear? Fine. Shall we go to the next problem? Let's do. Look at the next question here. He is telling that if the two circles touch each other, prove that fg dash is equal to f dash g. What are the two circles? X square plus y square plus 2gx plus 2fy is equal to c, and x square plus y square plus 2g dash x and 2f dash y is equal to 0. If you observe, we do not have constant for both the equation, then it clearly tells that both the circles touches at a origin. Yes. So, what is the condition? We have to find again C1, C2, R1 and R2 check the condition. Clear? So, let us write C1. What is C1 here? Minus G minus F. What is C2? Minus G dash minus F dash. Is it? So, can we find R1 and R2? Yes, right. So, my R1 is under root G square plus F square, and my R2 is under root G dash square plus F dash square. However, there is no constant. Clear? Then what is the condition? Given that two circles touch each other. Given two circles touch each other. So, condition is C1 C2 is equal to R1 plus R2. Yes. Shall we check the condition? See here. C1 and C2, that is under root minus G dash minus to minus plus G whole square plus minus F dash plus F whole square. Yes, that is equal to under root G square plus F square plus under root G dash square plus F dash square. Clear? Let us square on both sides. Okay, square on both sides. What do we get? Here square root will be get cancelled. And here we will get it as G square plus F square plus G dash square plus F dash square plus 2 under root G square plus F square into G dash square plus F dash square. Is it right? Okay. So, let us find a minus b whole square, a minus b whole square, and let us simplify. What do I get here? G square plus g dash square minus 2g dash, isn't it? And here f square plus f dash square minus 2f dash, okay, 2f dash. Here g square plus f square plus g dash square plus f dash square plus 2 under root. Let us multiply these both, or else let us put it like that, after squaring we will multiply. Clear? F dash ka square. Clear? So, if you observe g square, f square, g dash square, f dash square got cancelled. Yes. So, what is left more? Here minus 2g dash minus 2f dash is left. So, I can take it as minus 2 as common, g dash plus f dash is equal to 2 under root this term, g square plus f square, g dash square plus f dash square. 2 again got cancelled. Clear? Let us square on both sides. Why? There is one more square root here. Okay. So, it will be g dash plus f dash whole square is equal to g square plus f square into g dash square plus f dash square. Let us multiply. Clear? Here it will be g square g dash square f dash square plus 2g dash f dash. Do not get confused here. Okay. And the next, here multiply each and everything, g square g dash square, g square f dash square, and the next g dash square f square and plus f square f dash square. Is it right? Did we cover everything? Check. G square g dash square, this is g, do not get confused. Okay, g square f dash square, and the next g dash f square f dash f square. Clear? Check if something is cancelled, g square g dash square and f square f dash square will get cancelled. What is left now? 2g dash f dash, g square f dash square, g dash square f square. Clear? What shall we do now is, let us divide this g dash f dash on both sides, okay, or else let us take this term that side. What do we get? F dash square g square plus f square g dash square minus, let us write these 4 terms in this way, that will be 2 f dash g and f g dash, isn't it? F dash g dash is equal to 0. Clear? If you keenly observe, I can write it as f dash g whole square plus f g dash whole square minus 2 f dash g into f g dash is equal to 0. But this is in the form of a square plus b square minus 2ab. So, we can write it as a minus b whole square, isn't it? So, it can be clearly written as f dash g minus f g dash is equal to 0. Therefore, f dash g is equal to f g dash. Clear? Is it not easy? Only thing is, you have to be careful which is f and which is f dash. If you are not comfortable with this f and f dash, you can write it as capital G and capital F. Clear? It will be easy. There is no problem if you write like that in your exam also. Clear? Do you understand? Again the same process we have followed. Fine? Good. This is for today. Let us meet in the next session with the more problems of circles. Thank you.